start with why the heck. Apparently, we're all on a water theme, it seems. So I chose. Can everyone hear me, first of all, before I get started? Okay, so I chose ocean acidification for several reasons. First of all, when I taught this year when we did a global warming or climate change, the kids were bored to tears. They know it, they're bored with it. I know this stuff. Why are you going over this again? I know everything there is to know. And so I thought this was a good way to look at another aspect of rising levels of CO2 that they really don't know about yet, and frankly, it's not even in our textbooks. The other thing is I'm still not 100% sure what science I'm going to be teaching, and I really wanted to spend my time on something that I could use again. This topic is really cross-curricular, so whether you're teaching living environment or environmental studies or earth science or chemistry, there really are hooks in here either way. So um, the big idea for this project, besides the content, was that students would be kind of choosing their own aspect of the topic to investigate and designing their own experimental design to test some aspect of it. And we'll get to that later when we get further into the project. But my students really struggle very much so with experimental design, and they don't have a lot of experience with it, and they have a very hard time relating what the experiments that we do in class that are a little more structured to the quote-unquote experimental design that they really need to understand, both for the regents and also for good scientific experiments. So I thought having a project where they have a longer time to really explore designing an experiment from beginning all the way to the end, not just taking an experiment they see, but really figuring it out, would give them a much better chance at understanding what the process is like and why they're doing those things. Um, Another reason I've chose this topic is that this is starting to become more frequently covered in the press, but as usual, the press is they want an easy answer, and the science here is still a little murky, so there really isn't a clear-cut answer with things, that it's a little bit more messy. And I think it's good for them to see that in science there isn't always the right answer, that sometimes this is what we know, this is what we don't know, this is what we'd like to know, and this is what we really just need to study more before we can really make a conclusion. And then the other thing is this leads so nicely into pH, and that was something my students really struggled with this year, so it would give the opportunity for a more extended look at that concept and what it can do and what it means. So I'm going to pass it to Demetria now, who's going to just kind of give a quick rundown on the science of it, and then I'm going to take it back up with the actual project that the students will be working on. So Demetria, you want to take... Demetria?
I saw her disappear a moment ago, and I don't know if she's having any computer problems, because she was here all along, so she might sign back in. But maybe, yeah, you could continue until she comes.
Yeah, so I'll just... Now I don't see her in my people list. Maybe she got dropped off. I know she was having issues with Wi-Fi earlier, so maybe she dropped. So basically, I'll just continue with it seems to be the theme tonight. So basically, this fits in a lot of different areas, but in various curriculums. One is carbon cycle, which we have our little poster in the back there about the carbon cycle. And a lot of times when we cover the carbon cycle, we don't really talk about the ocean as being part of that cycle, and that is really a big problem. So this lets students see that that carbon is constantly moving back and forth throughout our ecosystem, and that the ocean plays a very big role in that, and the organisms that live in the ocean play a very big role in that. And so sort of showing them a little bit more complex understanding of the carbon cycle. And then, the chemistry is fairly simple. It's, carbon dioxide plus water, you get carbonic acid. That releases hydrogen ions, your pH lowers, and as we know, pH plays an important role in how we function in our environment. That when your pH gets altered, that can really disrupt a lot of life processes, whether we're talking about growth, reproduction, development. So the theory is that that would be potentially very bad for the organisms that live there. But ocean acidification is not just about the lowered pH. That's like the most common thing that they talk about in the press, is that it lowers the pH. But there's also the problem of changing the concentration of carbon. Carbon in the ocean, at least in its inorganic form, exists as dissolved carbon dioxide, as carbonate, and as bicarbonate. And for organisms that use carbonate to precipitate their shells, to create and build their shells, and we're talking coral, we're talking anyone with an exoskeleton or a shell, that if the concentration of carbonate drops too low, they don't have those raw materials available to build those structures. So as carbonic acid breaks down, it basically binds with carbonate to form bicarbonate, so it throws that ratio off. So there's just less of the carbonate around. So the chemistry, there's a big chemistry aspect of this, which has the potential for scaring kids, but also the potential for very cool reactions that you can see. So we saw, so when I did my research on the paper, you expected to see more of what the popular press shows, which you can see on some of the posters in the back, where you see those lovely shells of the pteropods, and over time they're dissolving in the pH. But when you look at the actual scientific data, you see a more complicated picture. You see certain organisms. Yes, I'll go over that when we go over the science project, because that's probably more as a demo or as a beginning experiment in the beginning of the unit-based experiment. So initially, just for what I saw from my research was that you had some organisms that really showed problems, such as the pteropods, such as those sea urchins, which you can see the larvae on that little spinning cube in the back. Other organisms really didn't show much of a change. And then you saw it, which was the more recent study, which was kind of interesting, if you see that poster in the back, those are coccolithophores. Those are a type of phytoplankton, which everyone was very concerned that because they create little shells back there, that because they make shells out of calcium, that they would be very affected. And some early studies had showed that their shells were not forming properly in lower pH conditions, but a recent study actually showed that their mass and their abundance was much higher in lowered pH or high carbon dioxide concentrations. And when they looked at deep ocean core samples, they saw historically the same kind of thing. So there may be, whatever the big picture is, most of these studies are looking at very limited, they're looking at one organism or one situation. And as we know, ecosystems are a lot more complicated like that. So even though you may have an organism that theoretically would do better, if its food source disappears, clearly there's going to be a problem. So it's a little unclear at this point exactly how it'll all be affected. But there's definitely a lot of room for more study. This is, a big problem, potentially. But we do see in the data that carbon dioxide is going up. We do see that pH is dropping, which you can see on the website if you look in. Hey, Dimitri is here. Dimitri, we were just kind of going over some of the evidence since we lost you. And I'm going to get into the unit. So we created the website kind of as a resource, and it can, and you can zoom in. It's on the table over there if you zoom in. So there's lots of information about the chemistry of how it works. If you click in there under that, there's a couple of experiments that I included both that I did and others I found in YouTube that either can be used as demos or can be used as in-class experiments. And they're very simple. The first one I did was just using one of those home soda makers to put carbon dioxide directly into tap water, basically making seltzer or carbonated water. And when you test that pH, you can see it drop very, very quickly and very strongly. Then I did some more less impressive experiments with just blowing, so more common to what you would do in a respiration experiment where you're capturing the CO2 in a balloon or blowing in it, blowing into it with a straw. You could do it that way too. And then I included some that used, I used probeware for mine because it was kind enough of Empire State to lend them. But, I don't have probeware at school, and many teachers do not. So you can also use indicators, which, while less accurate, kind of are a little more fun because you get that color change that really kind of wows the kids. So the other parts of this, so that basically yeah, I was thinking I definitely want to put in a request on Donors Choose and see if I can get some probeware. But anyway, so the unit, for me, the way that I thought of it, is that there's 3 stages. Now, ideally, you could use any parts of this that you want, depending on what you're teaching and what you have space for and what level you think your kids are at and how much time's left of the year. And what you're... basically, it's very, very flexible. But the way that I envisioned it was that there were 3 stages. And the first stage was doing one or more of these experiments in class, either as a demo or as a class experiment where they're seeing what's happening and then, seeing what's occurring and then making conclusions about what is happening. So that would be the first part. The second part is actually a virtual experiment that I found that was very nice through Stanford. And I just pulled it up on the page right now if you can see it. And I don't know if it'll link to it, but it's basically a virtual experiment. It can be a little bit long, but it's very precise. And it asks you questions as you're going through. Like, I believe at one point it asks you why you're rinsing your pipettes between sampling, or things like that, so that it's really testing their science process skills, which I thought, in addition to being on topic, getting them to practice those science process skills, getting to practice those measuring skills, because when you get towards the end, I don't think it's going to load, but